Uh, Problem is analysis of two-dimensional truss problems using finite element method and verify the result using ANSYS. Okay. So in this law, this is a figure. In this is a truss problem. Truss. What is my truss? This is a base link 1 to 2, 1 to 2 is base link, 2 to 3 vertical link, 3 to 1 incline link. ठीक है. Distance is given 800 mm, 600 mm, 1000 mm. ठीक है. And the one in node 1, that is a at this point node 1, it is a fixed support. Fixed and then node number 2 they will roller support. ठीक है. And the force is acting at node number 3. Vertical force of 10 kN and horizontal force of 20 kN. This is the problem. In this problem, so these are the links. Three links are connected. So this is triangular in shape, and the steel property is given. The links are made by the steel material, and this is the modulus of mass. Okay. Subjected to the forces of these two forces, vertical and horizontal forces. 30,000 is acting at node number 2. Horizontal lines. Okay. In the figure, there are two forces acting in horizontal directions, 20 kN and 30 kN. These two forces are about to sliding in this x directions. Okay, but it cannot allow to slide in y direction because it is a rolling support. Okay, in y direction, the vertical down force is applied, but there is a restriction at the ground at node number 2. That's why the deformation is not possible at node number 2 in vertical. But the deformation is possible only in x direction. Okay? There is a compressive load in between the link of 3 to 2. Okay? And there is a tension in the link of 1 to 2. Okay? What are the findings? We have to find out the nodal displacement. Then we find out the stresses developed in each element, and then the reaction force at the supports. This is the given information. What are the given information? Modulus of velocity E is given in Newton per unit square. Area of the ring is given. Then length of the first link, second link, and third link is given. And these are the P, XY, P3Y, and these are the forces acting in the at node number 2 and node number. So these are the given information for this. Now we proceed for the problem. Open the ANSYS APDL mechanical. Go to the first step. Here start now. Do not read the files. Okay. Yes. Next option. Change your name. Write the problem plus problem. Okay. Do you want to create error file or log file? Yes, I want to create error file and log file. Okay. Then we set the working directory. Go to the change directory and then select your working directory. So what is the where is it is? E drive. In the E drive, we select this folder HKW, the name of the working directory, in which all the files are saved. Now we proceed for the solution. The first step is preferences. We select structural analysis. Okay. Then second step, go to the preprocessor. Element types, add, edit, delete, add. Which elements we have to select? Link. First we have, it is not actuator, it is a finite strain 180 element. It is used for the link. So we select OK. Okay, and close it. Now we proceed. All the dimensions of the link are same. Sorry, all area of cross section. A1, A2, A3 of area of cross section of the link. All the three links are same. Material is also same. That's why we select only one element type. Okay, we select only one element type. So link 180 is the element type. Close it. Now go to the next real constant. We check the real constant values for this 180 link 180 element. There is no properties for available for real constants. Go to the material models. So select material props, linear, structural, plastic, isotropic. What is the value given in the problem? 200 into 10 raised to 3. 2E5, 200 into 10 raised to 3. Okay, and Poisson's ratio is approximately 2.28 for the steel ball. Okay, it is not mentioned in the problem, but we write the value of it. The next is section. So you want to define the section, go to the links, add, we select section ID number 1. Okay, okay. Now it asks for the name of the section. So we write we want to do this first section. Okay, you put 1. Okay, section name is 1, or we can put anywhere. If this cross section is rectangular, circular, or square, we can put the name, but we don't know about the area of cross section. That's why we just put the A1. A1 is the name of the, or only A is there. And what is the area of cross section? Area of cross 300 mm square. So we write the value of area of link area 300. So it asks for the mass per unit length. Okay, and mass per unit. If you know the length, if you know the mass per unit length of the particular link, then we can put the value. But we don't know about this, and all the links is under the tension and compression. So we select it for tension and both. Okay. Now I proceed for modeling. Okay, we will create. For modeling purpose, we create element. The element in element number 1 in between 1 and 2. Node number 1 and node number 2. Element number 2 in between 2 and 3. Okay, we select for element number 2 and 3. And for element number 3, we select node number 1 and 3. Okay, so we assume that node number 1 is at the origin. Okay, means the coordinate of the node number 1 is what? 0, 0. And what about the node number 2? Okay. Node number 1 at the origin. The coordinates are 0, x is a 800, 0. What about the 3? X is 800, 600. Okay. So we write the 3 coordinates. We assume that node number 1 is the origin. With the reference of the origin, we calculate all the remaining 2. Now we start to create nodes. Go to the nodes, modeling, create nodes in active CS. So node number 1 at the origin 0, 0. Okay. Okay. The first node at the origin. What about second node? 800, 0. Count figure. Where is figure? This figure. 800 mm is the distance in x direction. Y 0. Okay. Apply. Node number 3. 800, 600. Okay. So we create 3 nodes on the. These are the 3 nodes. First node at the origin, second node at this location, and third node at this location. So according to the active coordinate system, we draw 3 points. Now we create lines, straight lines. No, we don't create elements. We create elements. We create nodes. Okay, first of all we create a node. After that we create elements. Elements attribute. We decide the element is link number 1. Okay, all links are element types will be same for all the 3 links. We also create a material models. Okay, it is also mentioned in the here. Coordinate system, we don't know area of cross section is also defined here. We select A. Okay, and it is in the linear form. Okay, now we create lines, active auto number through nodes. So select node number 1 and 2. In between 1 and 2, the element number 1 is created. Node number 2 and 3. There is second element. Node number 3 and 1. Okay? Okay. This is the third element. So this is the structure For boundary conditions, we go to the machine. Sorry, uh, machine is not possible in this case because we create element, not a body. If we create body required to mesh. But in this case, meshing is not required. For boundary conditions, go to the loads, define loads, apply structural displacement on nodes. Select node number 1. As in the figure, it is fixed in all degree of freedom. Okay? Means it is fixed node, that's why we put the displacement value of all node is 0. Okay? So it is now fixed. Now we apply a rolling support at node number 2. So how to apply rolling support? We select displacement and select node number 2. Okay? Okay. So in which direction it is fixed? Only y direction. It restricts only y direction because it is rolling support. Okay. In loading support, there is a restriction. There is a restriction in the y direction, but it allows the slide in x direction. That's why we have to fix only two y directions. That is a rolling support. The displacement value is 0. In which direction it is fixed? U y direction. Okay? Now we proceed for the loading conditions. We apply a load. Adding node number 2 and node number 3 as shown in figure. Figure indicates there are two horizontal forces are acting at node number 2 and 3 respectively, and one vertical downward force is acting at the node number 3. So we proceed for application of load. For that we use apply structural and force and moments on nodes. We select node at node number 2. We select first node number 2. Press OK. What is the value of force? Value of force is 30 kilonewton. So we apply it at node number 2. We select node number 2 only. OK. In which direction it is applied? X direction. In X direction, vertical direction is the Y direction. So in the X direction, it is 330,000 Newton. Okay? Means 30 kilonewton force is applied in its positive X direction. If it is negative, we mark negative sign. Okay? Minus sign. So apply. This is the force acting at node number 2. At node number 3, we select node number 3 only. Press OK. In which direction is applied? Direction. What is the value? 20 kilonewton. 20 kilonewton here in this same direction. Okay? So it is positive value. So we have again click apply. Okay? Now we select there is one vertical downward force is acting in the downward vertical downward direction at node number 3. We select this. In which direction is applied? Y direction. What is the value? 10,000 Newton. Okay? But it is vertical downward direction. So we mark negative sign minus 10,000. Okay? This is the minus direction. If it is positive, then it is vertical direction. Downward direction is negative direction. This is the structure we want to create as per our problem. Now we will take a photo of this structure. Now go to the hard copy to the file. In which format? JPG, and press OK. It is stored in your folder. Now we proceed. This is the problem is defined, mentioned in the problem. So we go to the solution, solve, current LS. Okay? Okay. Solution is done. This is fraction of second we get solution. Now we proceed for results. We go to the results, general post processor. Okay? Then we go to the plot control, animate, deform results. In which direction? This X direction it is deformed. Okay? Because two forces are acting in the same directions. That is X direction. We select UX. So this is the result. Okay? So in the diagram, MX indicates the maximum deformation at node number 3. The DMX value indicates the maximum deformation value is 0.75. It is in mm. Okay? Because of this force, the deformation is possible. It is very small deformation, 0.7 mm. This is the animation. Okay, we slide the middle button of mouse. We get scale at the bottom. Okay, now we take a photo. Go to the dot control, R copy, file, JPG format. Okay. Okay. Now we proceed for the stress. Go to the plot control, animate, deform results. We find out the stresses and with direction 1 minus stresses. Okay, this is 3D equivalent stresses. We will do the trade. These are the stress. So no stress data is available for this problem. Okay. The animation is not possible for this. There is some error because sometimes what happens, the load is acting on the body is too much. The links or object is going to fail. So in that case there is some error will be generated. The data is not generated by the system. That is the force. Now I proceed for results list. Go to the list, results, nodal solution. Go to the nodal solution. We want to find out the reaction force, deformation value. Okay. In which directions? X directions. Okay. So these are deformation values. At node number 1 it is fixed support, it is 0 deformation. At node number 2 it is 0.4 mm. At node number 3 it is 0.7 mm. Okay. So this deformation is available, that is in UX1, UX2, UX3. Okay. Because we select only the UX direction, X direction. Okay. That's why it is this displacement value in only in X directions. Now I want to list out the results from nodal solution in Y direction. Previously we called calculate for X direction, now it is for Y direction. We select X. So these are the deformations available in the Y directions. Okay. So at node number 3, node number 3 there is a minus 25. Minus 25, node number 3. Means our this is the negative force indicate the under compression. The link is under compression and it is deforming itself. Next is going to the element solution. Find out the reaction supports. Reaction solutions, all atoms. Okay. So these are the forces minus 50,000 in x direction, minus 15 y direction at node number 1. Okay, there are two reaction supports, reaction forces at the node number 1. Because there is a fixed reaction, fixed support having two reactions, fixed reaction and y reaction. So this is available in the minus 50,000 in y direction and minus 15,000 in y directions. At node number 2, there is a only vertical reactions. Vertical because it is a rolling support. Rolling support मध्ये काय असतं? It restricts the vertical directions. It cannot allow to move in y directions. Okay? That's why the reaction will be generated at the ground. It is 25,000 Newton. Force is acting as a reaction force. Okay? So this is the find out the stresses. For stresses we go to the list, then find out the results. Find out the stress is observed in the element solutions. Element solution. So in this case there is stress in which direction, x directions. You can take anyone. Okay, one minus stresses we are also take. If you select x direction, yes, sigma x is there. So there is no value of stresses is there because excessive load is acting on the body. Sometimes it is going to be fail. That's why the data is not generated.